Welcome back, everybody. Well, if you read the title, then let's just get into it. What I'm going to show you is how to set up your KVM, set up your secondary GPU to be able to be passed through to the virtual machine. We're going to set up the Windows 11 virtual machine and make sure that we can use our GPU that we pass through into the virtual Windows 11 virtual machine. So this is really helpful when some of the applications that you want to use doesn't really have the Linux support. For example, I know like AutoCAD application or some of the printer application like the I meant the plastic printing, the 3D printing applications. They don't really support Linux. There are some open source application, but if you really want to use the Windows application, then you can pass the GPU through because there are some heavy GPU intensive tasks that they need to do. You can pass through the GPU and then you don't need to dual boot, and you can just use the VM to do your work. And when it's done, it's shut down. So I'll explain first, for the GPU pass through, you can either do there are some guides suggest you can do on the fly. You can do mod probe, or you can do on the fly GPU pass through, which I've tried but didn't really find any success with it too much. And the other one is when your system boots up, you can have the GPU to be loaded with the VFIO, they call it, the VFIO kernel driver, they call it, and it can catch that in the early loading and pass through, which is more, I think, more sure or more reliable, I would say, essentially. For the GPU pass through, you need to have one for your host machine and one for your VM machine that you're going to be passing. So you will need two of them. If your CPU has integrated GPU, then that's enough. Assuming that you're not going to do some heavy mobile game, heavy gaming or other thing that you need to do. If you just have the integrated GPU and one GPU, then you can just pass the integrated GPU, pass the discrete GPU to the VM, and still have your host be able to run your display. But if you're doing in the gaming or some other stuff in your host machine as well, then you probably should go with the option to have a secondary discrete GPU as well. And you need to be careful because your motherboard needs to support kind of isolating the PCI to pass through the GPU. So you need to pass all the PCI as in a whole to the virtual machine. I'll show you how to make sure that your GPU is isolated and passing through to the VM. So that's another thing. One more thing is you need to be able to, if you're putting two GPUs, discrete GPUs in your motherboard, make sure the power wattage and other stuff, you need to be considerate of it. You need to make sure the spacing is enough in your motherboard that you're able to support both discrete GPUs. So I had right now I have for example, if I show you, let's make it a little bit full screen. So if I show you, I have not installed FastFetch. That's fine, I can install FastFetch. All right, and we'll do FastFetch. All right, so as you can see, I don't know why it's showing Fedora here. Mine is not Fedora, so there's something wrong here. Mine is Arch Linux. As you just saw, I'm doing the, you can see Arch Linux, so this, I need to fix it. Either way, you can see I have the NVIDIA Quadro K620 and I have the AMD Radeon RX 9070, right? So what I'll be doing is I'll be passing through the NVIDIA Quadro K620 to the VM. I'll isolate the GPU. I'll make sure that when I boot my PC, it's being catched by the VFIO drivers. and then we'll pass it through the VM, right? Right now, you also need to make sure, like, I have my 850 watts of the power. What is it called? The I forgot what it's called, but essentially my CPU supports 850 watts of power. So if we look at the card here, you just need to make sure that so here I have the NVIDIA Quadro Case 620. So you need to make sure what kind of watt it supports. So this one is, if we go here, so this is suggested PSU. So 200 watt is suggested, and is saying is 45 watt of power it will consume. I have 9070 XT, which is let's see how much that supports. So if we find the 9070 XT, right? So let's see how much that requires around 300 watt of power, and is suggested is 700. So what I have is 850 PSU, so that should be more than enough to support both. So when you are doing dual GPU, you need to make sure you better be careful about your power supply and the wattage and spacing, of course, right? So let's go back and open it up. So first we can check if I open the LSPSI. So if you do LSPSI-K, you can see here that right now is using, where is my, here, this is my Quadro K60, is using the Novo driver, right? If you installed already like an NVIDIA driver or something, and it's using the NVIDIA driver, probably you can remove it. If you're doing the pass-through, then your host doesn't need that driver and the Novo driver will take over. That's perfectly fine. Or you could leave it if you do early loading, and I'll show you how to do that. But if you pass through it, then your NVIDIA driver probably won't catch that GPU anyway if you do something called early loading. I'll show you that one particularly. But let's go ahead, and first we need to do the KVM installation. So we want to pass through the virtual machine. So we want to make sure that we pass through everything to the virtual machine. So first of all, we need to make sure that our CPU, our PC supports virtualization, right? So for that, you can do ls CPU, and then you do grep, and then you do virtualization. And you can see mine supports AMD-read. So that means mine supports virtualization. You could, if it doesn't show, you might need to go to the BIOS and enable your virtualization. That way, it might show up again. So you have to look at your PC or laptop specifications and check if it supports the virtualization. You might need to go to the BIOS and enable it. It might be disabled, right? The next thing we want to do is we want to do zgrep config kvm, and we want to check the config.gz file. So here you can see, like, make sure everything is yes. That means it's going to be having the kernel level KVM modules essentially. So we want to make sure that we have the KVM modules enabled here, right? So I have already installed all the packages for QEMU, but I'll just show you in case. So you need to install QEMU full, libvirt, Virt install, Virt-Manager, Virt viewer, EDK2 OVMF. This is the image for like a UEFI boot for the secure boot and other stuff. That's fine. We'll do QEMU image -img guest fs tools and libos info, right? So if you do that, As you can see, I've already installed all of them, and you will see more dependencies here if you're doing a first time, because you're installing QEMU full. Then you're gonna probably see more, and once you do that, you should have the QEMU and install essentially, right? So the next thing you want to do is you want to set up the you want to download the Virt-IO image essentially. So you go ahead and let's go ahead and I'll show you. The Fedora has the virtual IO Virt-IO driver. So you need to get the driver ISO. So I'll show you where you can get it. So you can just search Fedora Virt-IO image. All right. So here you can see the direct download archive Virt-IO. So you can go ahead here and we can find the latest Virt-IO driver. There are stable Virt-IO and there is a latest one. I suggest you go for the latest one. And the latest one is you can see is 1.271, right? So I already downloaded it. So if I go to my data, you can see I have the Virt-IO image here, right? So that's perfectly fine. All right. And now you want to enable the libvirt ISO service. So we are installing the QEMU basically. So you want to enable the service. So you can do sudo system. Mine is already enabled, but you can do sudo system enable and you can do libvirt-service, right? So it's already enabled, and when you reboot it, it will automatically start, right? Now, generally when you do the QEMU, anything related to QEMU, you might need to do, or like Virt-sh or anything related to that, you might want to like you might have to do like sudo Virt-sh to access the system, you won't be able to do it without this sudo command. So if you want to use the sudo command, then you need to set the libvirt URI environment variable. So I'll show you, for example, this is my bash rc, ZS, the bash profile here, and you can set this libvirt default URI equal to QEMU//system. If you do that, then you'll be able to access the directly using Virt-sh command. You will need to do some libvirt. You will also need to set some configuration in the libvirt config that I will show you. So you can go ahead, you can go to cd/etc/libvirt and /. Let's go here, and you can go to you can open, let's just open this one here, and you can go to the libvirt conf. I think it was libvirt d. Yeah, so you can go to libvirt d configuration here. You will need to find, first of all, your libvirt sock group would be libvirt, and then you find the unique sock group rw comes to you need to uncomment this part essentially, and then there should be a, I believe in the QEMU there should be a QEMU config also. So go to the QEMU conf here, and you need to set your group. This is to be able to have the access to the virtual machines without the sudo user. So make sure you do all this. So let's just search user. Yeah. So go search this one where you have this example of valid value, the user for QEMU processes. So we want to be able to run the QEMU processes with our own user. So go here and set the user to your own, whatever the user you are using. For example, mine is Ken here. So you do that. And I believe that would be all. Yeah. And then just go ahead and restart your libvirt d service, and you should be able to access the QEMU using your own user rather than the sudo user, right? So now that that's the configuration for the QEMU. Next, you need to enable the IMMOU. Essentially, is the it's not called, it's known as the PCI pass-through. Is called the IMMOU for the AMD, and VT/X feature, or VT/X feature, VMX feature for Intel, right? So to enable that, you need to set up some kernel parameters. So for Arch Linux, you can go to etc/ if you install grub, then you need to do install/default/grub. You go ahead here. Sorry, defaults. Sorry, my bad. Here. You go ahead and nvim this. Sorry. Nvim etc default/grub. Yes, so you go ahead, and I don't know why this one, whatever, let's just close it. So go ahead and you can add the here AMD. I have it in the above, so just do exactly as is on mentioned and as is shown in the above line. AMD IOMMU is equal to on. So add this kernel parameter here, right? Then you do sudo write. Basically, I have this plugin in Vim that will allow me to open without the sudo, and then I can just use the sudo write to edit the file with the sudo command. So you can do sudo nvim, and then you can do it there. All right. Incorrect password, that's fine. I think it's wrong, so I'll do it again. All right. So I have added the command here. Now we need to remake the grub config. So let's go ahead and do that. So sudo mk grub, sudo grub make config /o, and where you have installed your bootloader. So mine is at /boot/grub/grub CFT. So let's go ahead and rebuild the grub config. Don't worry about that, it's a snapshot thing. But now that kernel parameter should be in the grub config. Now what you want to do next is I believe that would be it, and you just reboot your machine, and that should be that way the your KVM is installed, that particularly, right? So SPCU, so that way your KVM is installed. So now I'm gonna go ahead and reboot my PC, and I'll see you back in a second. All right, so I've rebooted my PC, and now you can go ahead and check you can do sudo dmesg, and then you can do grep -i. You can do VFIO also. So that's, will show you. Okay, so we haven't loaded the VFIO yet, but you need to check the AMD-VI. So you can see like the AMD-VI is enabled, the IOMMU part, right? Now we want to early load the VFIO drivers. All right, so as you can see, if you do ls pci-k, right now the kernel driver that the Quadro K620 is using is Novo driver. Now we want to switch this to be able to load it through VFIO driver. VFIO drivers is used to like grab the GPU and pass it through the virtual machine, right? So to be able to do that, we need to be able to in the image is called early loading, kernel modules early loading. So you can do that using the mkinit cpio. In the image, the kernel image itself, you can add the modules, and make sure that they are loaded early before the node driver or Mesa driver has a chance to grab a hold of GPU. And to be able to do that, let's go ahead and do the sudo. We will edit the etc mk init cpio config. So go ahead and do that. And here you can see I already had it above. So in the module section, you need to add VFIO underscore PCI, VFIO, and then we will do VFIO underscore IOMMU underscore type 1. All right. So let's do that. So that will load the VFIO drivers early on. So let's write it down. Give the password, and that's edited. So the etc/mk init cpio config is edited. Now what you need to do is you need to go ahead and rebuild the sudo mk init cpio-p.linux. So I have the Linux driver, Linux kernel. If you have some other kernel, you need to make sure you do Linux-LTS or Linux-Zen or Linux-Harden, and we will rebuild the image. All right. All right. The next thing we need to do is we need to make sure that we isolate the GPU, the PCI, and make sure we pass all that are in group. It's called the PCI grouping. We pass all of it into the VFIO driver essentially. And to be able to do that, there is a handy script that Arch Linux has provided. I'll show you guys. So you go here. And so if you go to Arch Linux, there is a handy script that they have provided here, this one. So just copy that and put it in some shell script. I already have it, so I will run it here. So I have copied this. So just search PCI pass-through via OMF on Arch Linux wiki, and you will be able to find this script, right? So I already have it, so I'll go ahead and run that script here. So and we'll do PCI groups. So I have put that in the grid so if I show you that PCI groups, so you can see I have put the scripts here. So we'll run that script, PCI groups.sh. So if you see here, so this is showing like all the drivers or all these all the hardwares that are associated with PCI groups. And if you want to do PCI pass-through, you need to make sure you have to pass all of them together. It doesn't work with if you just pass, let's say you pass the VGA compatible controller, this driver, but you don't pass this one, for example, the audio one. You have to pass through both. All right. So let's go ahead, and what you need to note down is the ID. It's called the PCI ID. So let's go ahead and note down the PCI ID. So here is 10DE, 10DE colon 13BB and 10DE colon 0FPC. So let's go ahead and open a new one. Maybe horizontal would be better. Yeah. So I have it here. 10. Where is it? Yeah, right. So let's go ahead. You need to go to you need to use the kernel parameters to pass it through the to grab them and pass this ID. So go ahead and we'll go back to the default grub. We'll edit it again, right? And here you can see I have put it already above. So you just make sure you do the same. So we'll do VFIO PCI .ids equal to 10DE 13BB comma. So that's our video graphics card, and now we will pass the audio one also. So 10DE 0F 0F BC. All right. Just double check is correct. Yes. All right. And we'll do Sura. Right. So we will edit the grub config again. All right. Exit that. So now go ahead and all right. So let's go ahead and first regenerate the image, so that because we modified the mkinit cpio config, we added the VFIO drivers in that one. So let's go ahead and regenerate the mkinit cpio config. All right. And then we'll do sudo, and then we'll regenerate the grub config also. Grub mk config. So let's regenerate the grub config. All right. All right. Now, lspci-k. So right now it's using no driver. If I restart the PC now, ideally it should be loaded through VFIO driver, right? And the no driver shouldn't grab hold of my graphics card. So let's go ahead and reboot. I'll show you guys once I reboot. All right, so I've rebooted my PC, and now we can go ahead and check whether our driver is loaded through the VFIO, our GPU is loaded through VFIO or not. So let's go ahead and do lspci-k, and let's check the NVIDIA Quadro here. So as you can see, the kernel driver in use is the VFIO PCI. So that means that we have successfully, both of them, the below one also, we successfully loaded our graphics card pass through to the VFIO, right? Now we can go ahead and create a virtual machine and pass it through the virtual machine. So for that one particularly, let's open up the Virt-Manager, virtual machine manager. It should be running. So this one is a previous one that I tested, but let's go ahead and create a new one. All right. So let's go ahead and do local install media forward. So I have so here I have, because I don't like the I'll show you. Essentially, I don't like the Windows 11 to be too bloated. So what I've done is, if you do WinUtil, just search WinUtil. It's a great utility by Chris Titus. And in that one, basically, if you have a Windows machine or something, you can run this command, the dev branch in it. And in that one, you can go to the micro-win, and it will be able to like automatically download the Windows 11 ISO, and then you can debloat it, and it will repack the ISO as a debloated one. So when you install stuff, when you install Windows 11, you don't have to go through the trouble of debloating afterwards. It will automatically be debloated beforehand. And you can set up a local account beforehand, rather than having to like kind of worry about having a network connection and then setting up a Microsoft account, which I think they have made mandatory, and there are ways around it, but this is much easier, I feel like, right? So I have created the Windows 11 debloated ISO here, as you can see. So let's go ahead and open up, and we'll create a new virtual machine. All right. We will set the architecture to x86-64. Let's go ahead and forward. We will select the Windows 11 debloated ISO. All right. And automatically you can select here Win11. That should be fine. All right. And let's do a forward. All right. Don't worry about this right now. I generally like to give 12 GB of RAM. 12 to 88, right? 12 to 8, 12 to 88, right? We can double check. 1024 multiplied by 12 is 12 to 88. Yes. So, and I have a 16 logical core, so I'll give it 8. We will fine tune the CPU pinning. It's called CPU pinning. I'll explain that later, but don't worry about this now. Just give it half of what you have. We will create a new one. So I will create a new volume. We will say maybe it's win 11 and we'll do test, right? We will give it probably, I think 80 gigabytes is fine. We don't need to allocate everything. So we'll create a new hard disk for that. And then we'll do finish, right? All right, then we'll do choose volume. And then we'll do forward. I don't particularly need the bridge network. You could do, the thing is, like, I haven't created any networks here because I have a dedicated LAN line that I'll also be passing through to the VM, so that the VM is directly connected to internet rather than doing a network address translation. So for virtual machine to be able to be connected to the internet, either you can do network address translation. Essentially, your Wi-Fi or whatever your LAN is connect from the host will directly pass the data to the VM. You can do it that way. You can create a bridge connection. That way your home network will be able to see your VM and it will be registered as a separate device. Or you could even just pass through if you have like a separate Wi-Fi dongle, or if you have a separate two LANs or something. So what I have is, like, my host machine is connected to the Wi-Fi, but my VM is connected to the LAN. So what I've done is I will pass through the LAN that I have in my PC to the VM, essentially. So my host is connected to the network via Wi-Fi, and my VM is connected to the network via my LAN. So we will do that. So that's why I have not created any network here. We will do the pass-through of the LAN also. So let's go ahead and finish that. I don't particularly need it, so we'll do customize before. That's fine. Okay. All right. So for this one, what you need to do here, this is fine, but here you need to make sure you select the OVMF port 4M. So let's go ahead and select that one. Yes, we'll save that. This is fine. CPUs, this is fine. We will come back to that. We will need to modify the, it's something called CPU pinning. I'll come back to that. We will have a memory. We'll come back to that as well. That's fine. So first of all, let's go ahead and add another SATA disk. So because here in this SATA disk, instead of SATA, let's choose the Virt-IO. And cache mode none, discard mode U and P. Now this is all some optimizations and stuff. I will show you that later. This one is fine. We will add another SATA disk, another CD-ROM here, because Windows doesn't come with the Virt-IO drivers by itself. That's why we downloaded that Virt-IO image, and we will load the drivers from that. So we will give it the Virt-Win here, which is fine. So we'll add two CD-ROMs here. For the boot, we will say boot from the CD-ROM 1. So that way the Windows installation can get started. We don't need the tablet, so remove that. We don't need the NIC, so remove that. All right. Display, we will give, this is fine. We will select the display for now. First, we will install the stuff using the display splice and other things. Then once the driver and other things are set up within the virtual machine, we will remove the display splice and other stuff from here, right? We don't need the USB redirector. Okay, fine. We'll leave it for now, and then we will remove it later. This is fine. You need the TPM emulated, and you can do here version 2.0. CRB version 2.0 emulated. All right. Now, what you need to do is we want to do something called CPU pinning. So if you go ahead and look at our Arch Linux blog post, I'll show you. Let me minimize that. So if you do performance tuning and CPU pinning, right? So essentially what it means, like your CPU has something called logical cores and the physical cores. So when your virtual machine pass through the core, so we give it like, let's say 8 cores, it doesn't really specify whether it's what logical core it will pass. It will just do pass as random. And sometimes it will like within one physical core, one logical core is to the host and one logical core is to the VM, which doesn't really, it's gonna cause like performance degradation. So what you want to do is you want to split the physical cores in the half, or however much you want, and pass those physical core as a whole to the VM. That is called CPU pinning. And for that, what you need to do is, let's go ahead and let me do it like so. Let's go ahead and do ls CPU-E. It will give you your architecture of the CPU. So ls CPU-E. So as you can see, I have here 16 cores, so 0 to 15, right? And in that one, you can see the number of the if you see core 0, so the 0 and the 8 is one physical core. The 1 and the 9 is the same core, basically. So 0, 8, 1, 9, 3, 10, and so on, essentially. All right. So when we pass through the GPU, when we pass through the VM, we want to specify which one we want to pass as a whole unit, right? And to do that, we need to like edit you need to manually edit the XML. And for that, you can go ahead and I believe you need to first go to preferences, and you need to do enable XML editing and enable libguestfs. This is optional, is fine, but you need to do enable XML editing, right? So now I have already done I have already know like how my CPU configuration is, and I have set it up on the side. So if you want to know, so let me go ahead and open my dot file. If I go to my dot files, let me just go that, and I have it here, my XML. So you can take a reference to that XML and modify accordingly. So as you can see here, my vCPU is static 8. So you want to do like add, copy these IO threads 1. So what we are doing is, here is a CPU set, right? vCPU 0, CPU set 4, CPU set 12. So it's like IO thread 1, CPU set 0 to 3 and 8 to 11, right? So if you see 0 to 3, so we want to pass 8 cores, right? Essentially, so we're doing vCPU 0 and the set is 4. So if I go back here, just give me a second. You do not need all cores for the guest. It would then preferably to leave. So here it says CPU core 0 is sequential with CPU 0 and 1. Whereas Intel places core 0 on CPU 0 and 6, right? AMD core, but here is different, as you can see. It's 0 and 6. Mine is core 0 and 6. So even though I have the AMD, I don't know, maybe this is wrong. All right, I don't know. But mine is like, you can see 0, and here is this 8, essentially, right? So, right. So if you look at here, right? So and compare it to this one, the vCPU is just a number, index, essentially. Oh, this is my first one that I'm passing. This is the second one I'm passing, third one. So it should be, we have 8 of them, right? And the CPU set is the CPU node here, the first one, right? So we want to pass where it matches with the other one, right? So essentially, let's say I'm passing the CPU set 4, so here, and my core is 4, so my physical one is 4. So ideally, what I want to do, I want to check what the other 4 is and pass that 12. So the second one I'm passing is 12. So this is a group. So I'm passing 4 and 12, which are logical one, in a group called core number 4. So I'm passing them as a both. And then essentially 5 and 13, and then 6 and 14, and then 7 and 15. So as you can see, 7 and 15, right? So this is my one physical core number 4. This is my second physical core number 5 here. This is my third physical core 6, and this is my fourth physical core 7. The other one belongs to the host, right? We want to do emulator pin, so CPU set 0 to 3. That means we are giving it 4 cores, right? Physical ones, right? IO thread 1, and here you IO thread 1, and here you do the other one, the exclude, basically the CPU set other than what you have passed. You just set the other ones here. So for example, I passed the 5, 6, 7, 4, 5, 6, and 7 I have passed, and I passed 12, 13, 14, and 15. So 0 to 3 and 8 to 11 that I need to pass here, essentially. All right. And you want to make sure you have the IO thread 1 set here, right? So let's copy this, and we'll put it into the our here. Remove the vCPU here, and we'll put it here. That we're gonna do a static placement here. All right. Okay. The other thing you want to do is you want to go ahead and have some of these set here. So I've done that. It's just some optimizations that you can look into, essentially. You want to do the CPU. Let's go ahead and check the other CPU stuff here. CPU, where is the CPU? Here. Yeah, so CPU host pass-through, right? So I think you need to change this one also, CPU mode. So we'll go ahead and check the, where is my, close this one. Let's find here. Yeah. So let's find the CPU here. Here. So you are giving one socket, one die cluster. We are giving 4 cores and 2 threads. And we are doing cache mode is pass-through, feature, topo ext. Don't worry about it. Just copy paste this. And we will pass through here in the CPU pass-through. All right. So let's do that. All right. Topo ext, right. All right. So that's done. Now, another thing you could do is something called huge memory pages, but I'm not gonna worry too much about it. There is another, like you can allocate the memory like backing and other stuff as to increase the performance. If you want to do that, just let me know. I can show that to you. But for now, I think that should be it for the CPU pinning, right? Let's go ahead and check the, yeah. So as you can see, that this is the topography that we manually set, and we manually pass the 8 CPU cores, for example, right? And the next thing we want to do is we want to now go ahead and add hardware. So, and then in hardware, you want to do the PCI host device. So now we're going to pass our LAN and our GPU to the virtual machine. So what you want to do is, let's go ahead and pass our LAN. So my LAN interface is this one. So you can check here, interface ENO1. So we'll pass the network. Yes. Don't worry about it. It's saying I'm already using another one. You don't need to worry. It will give you a warning if you already passed through it in other virtual machine, but as long as that virtual machine is off, then you don't need to worry. Then we'll go ahead and do PCI host device, and then we'll find the Quadro K620. So you have here, and so both of them you need to pass through, make sure. So this is the video one and this is the audio one. So let's pass through video, and then we'll also pass through audio. PCI host device, we'll pass through audio. All right. All right. Okay. So now we passed the LAN, we passed the Quadro K620 audio, video, and we passed the GeForce, the audio, right? What else? I don't think you need the redirector. So let's just remove the redirector, USB redirector. So let's remove that. We don't particularly need it. We'll keep the channel spice now, but once the graphics card and other things are set up, we'll remove that. So let's go ahead and do begin installation. We have the Virt-IO here. We have the boot option. All right, so let's do begin installation. We'll minimize this. All right. So we'll do boot from CD. Yes. Let me maximize that. All right. So as I mentioned, this is already like kind of debloated ISO that I'm doing. So, and I already set up the local account and everything beforehand using that WinChris utility. If you just download it directly from the Windows ISO, that's also what's fine. You just go through the normal Windows setup. So let's go ahead and next. That is fine. Next, we will say I don't have a product key. We will enter it later. If you have it, you can go ahead and add that. So let's go ahead and search for it. So here it will say you don't find any disk. So what you need to do, you need to load the Virt-IO driver. So you can go ahead and browse, because we mounted the Virt-IO in here. So go ahead and you need to do the VIOSTOR, VIOSTOR. We'll do Windows 11 and AMD 64. So you need to do Red Hat Virt-IO SCSI controller. You need to load that driver, and then you'll be able to see the disk. All right, so we got the 80 gigabyte of the disk. Let's go ahead and do next. All right, keep nothing, and then we'll do install. All right, so let's wait until this is done. And I'll be back when this is done. All right, so I think it's done installing, and now it's doing a restart. So let's go ahead and check. I think the initial phase is done. So I think for now it will say like, oh, please wait while we get things ready. Okay, it's still installing, which is fine. So hopefully it won't take long, but I'll come back when this is done again. All right. All right, so it's ready. So let's go ahead and make it full screen. So upside, as you can see, it's already set up my local account, so I don't need to go through that things again. So let's go ahead and install, login, sorry, not install. All right. So it may take a minute to get things ready for you and blah, blah, blah stuff, the usual Windows stuff. Oh my God. All right, I'll be back when this is done. I don't know how long. It may take a few minutes, but who knows? All right, so as you can see, even though I debloated, it's still asking me to like install the WhatsApp. But as you can see, it's debloated and with minimum installation. And now we're gonna install the GPU should have been passed through. So if you can go ahead and do device manager, as you can see, it's showing two display adapters, but we haven't installed the drivers yet, so it's not showing which one it is. So we need to do that, and plus we will install the Virt-IO drivers also. So just because you already mounted the Virt-IO things. So go ahead and first go to the Virt-IO win and just install the guest tools. So we'll do the install the guest tools. Next, I accept the terms. So we'll install all of them. Let's go ahead and install all of them. All right, finish, display, QEMU agent, guest agent. All right, done. The next thing we want to do is we can go ahead and to display settings, device manager here. So you can see that it had Virt-IO and it has the NVIDIA Quadro key. So we can do the update driver and search for drivers automatically. Search for drivers on Windows Update. We can you may want to do that Windows Update stuff, which is fine. Let's do a restart first so that the Virt-IO are all done. Actually, I should have, sorry, let me, oh my God. I booted from the CD. Let me remove the CDs first. So yes. So I'll be back when just give me a second. I don't know what's going on here. My mouse is not being able to. Oh, okay, now it's detached. All right. Let me do that, and let me just force shut down this. All right. All right. So what we want to do is let's remove the SATA ROM one. We don't need it anymore. We don't need to delete it. Let's remove this. So we'll delete that. The disk is fine, the channel files, all these things are fine for now. We want to be able to, let's run this. Right, so we remove the CD-ROMs and we will do, I think we installed the Virt-IO drivers. So for now, it should be like you should be able to get it through. Set the resolution. So we'll do display settings. We can set the resolution. I believe is this one. That's fine. We can just do view scale. Always okay. All right, resize to VM. That's fine. Let's do this. Uh, uh, all right, whatever. For now it's fine. I'll show you the how to properly do that. But NVIDIA Quadro, so we still need to install the drivers for NVIDIA Quadro. So what we're gonna do is we're gonna use the Windows updates to do that. So let's go to the settings. You can also use you can also do the if you have other and you already have the drivers for it, you can manually install it using the drivers, but I'll use the Windows update to install the drivers, which is fine. Oh, you know what? I can do the NVIDIA Quadro. I don't need that. I don't need that. I don't need that. So we'll do NVIDIA Quadro K620 drivers. Let's do that. And let's just Quadro. Is there no Quadro? Is this RTX series or is this K series? Just Quadro series, right? All right. I will do Quadro K620. This one. All right. And we'll do Windows 11. I will do fine. All right. I mean, for sure, this one should work essentially. So if you go to the advanced, it should show like optional driver update. It should show like the NVIDIA display, right? Which is fine. But we can just install using this RTX one. All right. How we can download. What's going on? Why is it flashing? Hello? What? This is so annoying. All right, we'll do that. All right. Actually, doing this way is also fine here. So, oh, it's gonna do the whole cumulative update and blah 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 stuff. I don't particularly like it, but whatever. So I'll be back when I download the drivers, and I'll show you guys. All right, so I've downloaded the NVIDIA driver. Let's go ahead and install that. And this is a bit annoying. I can, well, whatever, let it download on the back end. We're gonna install the NVIDIA display driver. All right, so agree and continue. We'll do express install, which is fine. We just want to make sure that the driver works. So we'll keep this open on the side. I don't know why it's showing NVIDIA display 27.21. All right, it's installing the graphics driver. Oh, why it's taking so long? All right, let's be patient and while it's installing, I'll be back once the graphics driver installation has been done. All right, so I've installed the graphics driver, and as you can see, it's showing it properly, NVIDIA Quadro K1620, and it's showing like this device is working properly, right? So now, if you go ahead and check your task manager, right? And if we go ahead and check the performance, you should be able to see your GPU 0, and it's using the NVIDIA graphics card. Now that we've done the NVIDIA graphics card, what you can do is, let me check my IP. So my IP is 332. Okay, 332. All right. So what you could do is you can just go ahead and shut it down. You can first set up the auto login. So the easiest way I found is go to the WinUtil from the Chris Titus tech utility. Where's the GitHub? It's the user guide. GitHub here. All right. So we'll just copy this, open up the PowerShell. Let's open up the PowerShell. Just run it, and it will say, oh, use the Windows administrator, which is fine. So you can use this to debloat your machine, but what I like about this is it has a nice auto option to do auto login, because I don't need to worry about, I just want to kind of make sure that once I start my machine, I want to directly go to the window, the desktop. So we'll do setup auto login. So let's do that, and we'll say, oh, well, put my password here, enable. All right, so that's fine. And then we'll set up a remote desktop here also. So let's go ahead and set up a remote desktop. Remote desktop connection. No, not this one. Set your remote desktop configuration. Remote desktop setting, yes. So we'll enable the remote desktop. And we'll add our this scan already has the assets, which is fine. Okay. All right. So now we can, so we set up a remote desktop here. So now we can do is we can go ahead and shut this down. And we'll remove the display spice and the VM, and the other graphics driver we are using the Virt-IO driver for. So what we can go ahead and do is let's go ahead and remove the display spice. We don't need the Virt-IO spice, the video. Serial is fine, sound is fine, all of this is fine. So now we can go ahead and just run this. So now you won't be able to see it here essentially because it says graphical console is not set up, but we'll wait until so it is running Win11 too. So what we can do now is we can use something called Virt-Manager or free RDP, whatever works. I need to install Virt-Manager. So let's go ahead and Virt-Manager. We'll install the Virt-Manager. So that's used for like connecting to the remote servers essentially. So we'll RDP, use the remote RDP. So let's go ahead and do Virt-Manager. So we have the RDP here. So let's go ahead and do that. I believe we'll do RDP remote desktop. So we'll put our IP address here, 3.32. I believe it was 3.32. If you don't know which one was it, you can just check your Wi-Fi connection and check it there, right? Or you could assign a static IP also from your Wi-Fi router. All right. We'll do use client's resolution. We wanna be automatic. This is fine. And in the advanced, I wanna do like best. And there was audio, right? So audio output will do local. So whatever we run in the machine, we can say here we have the connect, right? So let's go ahead and do save and connect, accept. And now we should be able to log in, right? All right. So now we can do a full screen here. Toggle full screen, and we'll do toggle scale mode also, right? So now that should be like your Windows running, right? And you can see having the NVIDIA control panel, and you can do personalize. So and it's using and it's much smoother because you're connected using RDP, and it's a performance, and it's much smoother, and you have your GPU here. So now you can probably properly install your virtual machine, the apps that needs the GPU, and it's working fine, right? Well, and that's how you do the whole GPU pass through and everything. Let me know how you like the video. Leave a like and subscribe and comments. If you have any questions and anything, just put it below in the comment section. And yeah, happy to see you in the next video, guys. Bye.